Welcome, and thank you for joining us for today's webinar presented by DME. I'm your moderator, Christina Fugis with Mold Making Technology, and today the topic is Integrated Product Solutions for Advanced Molding Operations. Our presenters will talk about modern approaches to injection molding operations and how to implement some technical solutions, including collapsible cores, temperature control systems, and cooling management solutions. Our presenters are all from DME. We have Michael McCutcheon, Senior Product Manager, Jeremy Such, Senior Product Manager, Hot Runners and Control Systems, and Neil Beezer, Regional Sales Manager. Before we start, a couple of housekeeping items. If you're listening, you can ask questions during the presentation by typing them in the Q&A tab on your screen, and we'll hold on to them until the presentation is over, and we will get to as many as we can. Make sure you check out the Handouts tab. There is a bunch of additional resources in there, so check that out. And lastly, we are recording this webinar so you can listen to it later online. Now over to you, Mark, to kick things off.
Sure. Thank you, Christina. And hello, everyone, and thank you for joining us for today's webinar. My name is Mark Zaborny. I am the marketing manager here at DME. What I want to do is kind of take you over through today's agenda. What we're going to do is we'll have a quick, brief overview of DME, and then we'll go deep dive into several compelling case studies. These case studies will showcase our solutions that we have, including with our partners that we have with Cooling Care, Servomold, Crytox, and AHP Merkle. A little bit about DME. For more than 80 years, we've been a trusted partner in the molding industry. And our philosophy has always been simple. We focus on the part. We have over 60,000 SKUs in our catalog, and we're not just a supplier for you. We are your solution partner. Whether you're facing complex mold making challenges or you need guidance to get that job done right the first time, we're here to show you how to get success every step of the way. Before we begin, I want to make sure that you guys know how to contact us, to reach us if you need to. I put in the chat ways that you can get a hold of us. Easiest way is to contact our sales reps that you have. If you don't know your sales rep, you can go to dme@dme.net, and we will get you in contact with the person you need to. Also, if you haven't already, please join up on our e-store at store.dme.net. Where you can view all of our product offering that we do have. Our team is always ready to help and serve you, and we are there when you need it. Now, without further ado, let's dive into our first case study, and I'm pleased to turn the presentation over to Mike McCutcheon. He's going to talk about Cooling Care.
All right, good morning, everybody. This is one of the funner items that DME sells to talk about and go over. So we can start with the first slide here. So this is really what the problem is that we try to solve with Cooling Care. No matter how you treat your water, if you have a closed loop system or if you have just an open system, you're going to end up with scale, especially with the heat and the tight passages through the mold base, especially if you're using any type of bubblers or conformal cooling, you're going to get some buildup in there sooner or later. So this is what we see: scale, iron oxide buildups within the cooling channels. They start off nice and free flowing. You set a baseline at the beginning of the mold when it's brand new, and then as you see, as the heat and the scale and rust buildup start to happen, the channels get insulated. And then the flow gets less because of the less surface area. So heat transfer is less, and that's just like an insulation blanket going on the inside of that cooling channel there. So we want to prevent that. That's going to start causing you to have product issues, longer cycle times, to name a few. Those are the main two keys to start seeing that if you're not monitoring your flow rates. So next slide here. So our solution is the Cooling Care. We've had this in the market now for probably a good 6 years, I want to say, but it's really a cutting edge technology, user-friendly interface with the PLC. You're able to download information. You can store up to, I believe it's 3,000 tools. So you can manage that really quickly, bring the tool over to the bench and just pop in that tool number, and each circuit will memorize what the flow rate should be, so that there's no guesstimating on, well, how is it clean, is it not clean, where's my flow rate, what should it be. It's already stored in that PLC. So very high-tech machine that also includes heat, pulsation, the pump, of course, and those are, and then the media that we sell also with it is a really good combination, one of the best in the industry, in my opinion. So next slide here. One of the keys or the patented processes that the Cooling Care offers is called the cavitation process. And we have a video on the next slide here to show how the pumping in the system. We can go ahead and play the video here, and you'll get a visual of what's going on inside each of the cooling channels. So as you can see, as the cavitation happens, the bubbles within the channel, they start to compress, and they actually start to implode here. And what that does is it releases steam and does a steam scrubbing within inside of each channel. And that's really the patented process that Cooling Care offers that nobody else can match in the industry. Right there, you see the implosion, and that's the scrubbing action. There's some other competitors on the market that try to mimic this with injecting compressed air, but they're not getting this implosion and the scrubbing action. And then you pair that, like I said earlier, with the chemical and the heat, and then this implosion action. It's the fastest cleaning machine on the market, bar none. So this would be the ideal process, and this is what's happening inside the channel to really scrub and break up those particles. And in the later on, you'll see the outcome and the chips and the products that come out from this process. It's pretty impressive. We like to call it gold because it's kind of like mining for gold, and it comes out in big chunks like nuggets of gold. So it's kind of interesting, and it's money that you'll save. All right, so next slide. We get into our case study. In this case study, what we did was we used the CP2 Duo machine, which is one of the newer machines that we've offered. I think we launched this about a year and a half ago. And it's a really nice, affordable machine with 2 zones of pulsation and cleaning. And then it comes with the tank on top for neutralization. So this is a really nice machine at an affordable price with a little bit of manual work to it, but it still gets the job done. Patented cavitation, just like all the other machines. It will measure and test for any leaks, measure your flow rates. It still comes with the PLC to manage all that. So next slide. So this is where where we get into the case study itself. And what happened was we have a really small 4 diameter cooling channel that was plugged in this and causing major problems in production and quality, longer cycle times. So we took on the challenge with the Duo machine, and this is the setup currently. So go to the next slide, please. You can see there the 4 millimeter diameter is kind of highlighted on the right, and the machine's hooked up to all the cooling channels there. Next slide. In this slide, you can see where you can actually set up the timing for the cavitation and the pumping actions. So everything's you're able to manipulate all the different settings within this machine, which makes it really nice. It's not just I'm going to set it up and let the pump go. You can manipulate it to get the best action out of it that you need, and get the fastest way to unblocking any type of block cavitation or conformal cooling insert or anything like that. So, it gives you all the information, like I said earlier, like your flow rates, your pressures, and everything like that. So next slide. So what we did was this one was plugged. So we like to get called in when we have some major problems to get solved, because we usually can come through on it. This is one where the we added a little T valve here so that the machine could fill it up, fill up the channel, and make sure that it's getting all the water and everything to the source of the plug. Go to the next slide real quick here. So this shows you right here what the steps are. We fill everything up, and then once the pressure meets its maximum of what you set it at for that particular channel, it will stop, right? And then the cavitation pumping action from the diaphragm starts to try to pump, but it can't because it's at the maximum PSI, and there's just no room for that liquid to move back and forth. So what we do is crack the T valve slightly and let a little bit of the pressure out, and then that diaphragm will start moving back and forth. And as we showed you earlier, it's going to move that water in solution, and with the heat and the chemical all mixed together, starts to eat away at that breaking point, or that plugged area. And within I believe 4 hours of this one, we were able to break that free and get free flowing water to go through and start cleaning out that channel completely. Next slide, please. So this helps. So it's not so manual of turning off the valves and moving everything around within the system. Just the little crack of the T valve is what we're showing here is really all that was needed. Next slide. And this is when you don't have a blockage, you can just hook it up directly with your standard cooling hoses. You can see this is in a tool room here, and it's just a standard maintenance process. And this is where you'd want to be, where whenever your tool is down for maintenance, you throw it on the machine, let it run through the process, and say, okay, this is tool number 1, 2, 3. All my channels are flowing to the flow rates that they were originally set to flow at when I first entered this tool into the PLC when it was brand new. And the machine will stop as soon as you meet those flow values again. So you're not wasting a lot of time. A lot of the other products on the market are just plug it in and you let it clean, and you don't know if you need 2 hours, 20 minutes, or 8 hours to figure out if it's clean or not, because everything is all right in this system here. It tells you instantly, and you're not wasting a lot of time, and you can get it onto the next tool that's needed. Next slide, please. So this was kind of the gold that we got out of that plugged unit there, and it shows the flow rates there in the upper left-hand corner from the PLC, how they went from 7 to 12 and 7 to 12 there, and I'm sorry, I can't really see that very well, 4 to whatever that next number is for percentage there. So it's major flow rates increase there, and cleaning out the channels. You can see the pictures from the endoscope on the left and right, and you can see how dirty those were. So it's just all that scale and line build up. And again, you get these pieces that break free, and it's pretty impressive machine that this kind of pumps that right on out of there. And it's really just hindering your heat transfer big time. So next slide. This is what we have to offer. We've expanded the line, as I stated earlier. There's a CP series, which is the good product. It's very simple to use, typically a single zone, has pulsation, but typically does not have heat. So you save some money there, but you may have a little bit longer cleaning time without the heat. The CM and CMS series, we have a couple different series there. That one does have the heater option, and then it usually comes with an optional pulsation zone, typically 1 zone for those, and comes in 4 to 7 zones of the pumping action just to get the material through the tool itself to clean it. If you have a good maintenance program going, and you don't let your systems get plugged up, and you don't inherit tools that are really gummed up, the CM series is a really good series to employ in your operation. You don't really need the pulsation as much if you don't have really gummed up tooling, the chemical and the standard pumping will clean everything up pretty well. So next slide, please. And then we have the CS, which is like a semi-standard, has almost everything the CA has, which is a semi-automatic, but it just has a couple valves on top that need to be manually moved to reverse flow and change on to the pulsation and things like that. So again, you can save a little bit of money, but a little bit more manual work. The nice thing about this unit is that the PLC walks you through every step and will highlight which lever needs to be turned in which direction. So it's very user friendly. Next one. And this is the flagship unit here. These are the CA units. It has everything. You just pretty much hook it up and put in the PLC which tool you're utilizing and which channels that you hooked up to, and just let it go. You can put it onto the cleaning section and it will do all the testing. It will do the air pressure tests, the flow tests, and then once those all pass, it will go into the cleaning mode. And if you set it to the return to normal mode, it will clean until that has been achieved on those flow rates. And then it pushes out the cleaning chemical back into the tank, all contained with compressed air, and it blows it out. And then it has a diagnostics tank with clean water that it runs through and does all your checks on flow rates and things like that. So really cool unit with all the bells and whistles. Has Industry 4.0 connection. So if you hook up a SIM card to it, it can tell you, give you a text if there's a problem where it stopped or if the cleaning is done. So really interactive units. Next slide, please. This is online, so I'm not going to go over it right now, but you can compare all these units online with this data sheet here and see what one fits your operation best. Next slide. A couple more small case studies. 200 conformal inserts were fully blocked. Customer was considering a full replacement of the whole fleet of these at the tune of $250,000. This is where Cooling Care really shines, is these conformal cooling inserts, to hook them up and really use that cavitation process to get those unblocked, because you have so many contours and small dimensions within the conformal cooling arena, and those are expensive. So you want to make sure that you can save those, keep those clean, and keep them operating to their potential, because that's what you invested for, right? Is to make sure that you got a really nice part out of there in a quick amount of time, and this is really what you need to clean those up and make sure you're getting the best out of your investment. So no cost to replace those or have them made, or even wait for them to be made. Just hook up the Cooling Care machine, and within a few hours you'll have a insert ready to go. Next slide, please. Same with bubblers. Bubblers are super standard, right? The dimensions on these get pretty small, 2 millimeters in this one. Typically, it was taking 5 days to pull that tool out, disassemble it, clean them up, or buy new bubblers. Again, another 2 to 4 hours of cleaning and increase the flow by 200%, through these bubblers. Next slide, please. I think this was kind of a repeat. We can skip that one. Yep. And so that's it about Cooling Care. So if you have any questions on that, please enter them into the chat, and then we'll get to them at the end. And then I just also want to talk about FlowSense really quick. On the next slide is if you're utilizing the Cooling Care, or even if you're not using Cooling Care, this is a really great tool here. It monitors all your flow rates, gives you temperature, pressures, delta T's, everything you need to know about your cooling channels. It comes in multiple arrangements depending on your application. There's the FlowSense 1 in the bottom right. It will do temperature, pressure, and flow rates for a single zone. The 2 on the kind of in the middle there on the bottom is more of a stainless steel option. So if you need stainless steel manifolds, and it has the separate readout there with the cord. The 3 and the 4 are identical units. The 3 is just mounted right to the manifold itself, the water manifold, and that's in the upper right-hand corner there. And then the 4.0 is on the left. You can hook up to 4 different manifolds there, monitoring 48 zones of cooling. And you can see you can set flags for ranges on your temperature, your flow rates, your pressure, all that, and it will send out a signal if one of those is out of range. And you can, if you can see the screen there print on the top, you can see the ones that are red are out of range, orange is getting close, green is good to go within the parameters that were set for that. And then you can switch through each manifold and monitor each zone, or I'm sorry, each manifold to get down to each zone. So really nice technical units there. And that's all for me. So if you have any questions on any of this product that I went over, please put something in the chat there. I'll be happy to answer it later on.
Right, Jeremy, your mic might be muted.
I apologize for that. It was muted indeed. Yeah, Jeremy Such here, and just want to do a quick overview of a servo mold application and then talk about latch locks for a few minutes. So Servo Mold is a German company, and DME is the exclusive partner of Servo Mold for the United States and the Canadian markets. So we work closely with them when a customer brings an application to us. They engineer and design the system to meet the application needs, and then DME facilitates the installation and startup of that system here in North America. So servo mold, it could be either an unscrewing device or it can be used for plate movement. And when used for plate movement, the plates can be moved in increments of 180 degrees or 120 degrees. And as we're going to be looking at here as an unscrewing device, there's several different types of configurations that can be put together to meet the application need. What I do want to highlight here is that servo mold is a fully engineered system. Servo does have some standard configurations as far as drive mechanisms and so forth, but every part, every mold is looked at separately, and the system is designed very specifically for that. As its name implies, electrically driven motors with encoder feedback for control. In an unscrewing capacity, we could go from 1 up to potentially 96 cavities of unscrewing. It's clean room suitable, so it's good for food and pharma. No hydraulic oil or other things like that to worry about. Very compact designs, and when necessary, cooled cores can be provided. So basically, we can go to our next slide here, Mark. And I'm not going to go through each one of these, but if you would just quickly look down the column on the left-hand side, you can see the technical information that we like to gather at the beginning of an application review. And, there are many, physical and mechanical things that have to be considered, regarding the size of the part, the length of unscrewing, the torque required, so that's going to involve the resin that's being used. So we can go to the next slide, Mark. And so what we have is basically a quote request form, but really it's more of an application overview, where when a customer comes to us, we're going to want to gather all of these, general parameters in the beginning, and give as much information to the engineers as possible so they could start crafting a system. In this particular application, this was a pharmaceutical part. ABS was the resin, and the intent at initial design was for a 64 cavity mold. So again, based on that part size, the length of the unscrewing and so forth, servo mold went to work with our application engineers. Next slide, please. So again, just as a part of the design, so Servo has a number of different, I think I may have said, standard configurations of the drive mechanism. That doesn't necessarily mean standard in size. It just means standard in configuration. So in this particular application, we were looking at actually one drive that through a series of contained gears, we're going to drive 6 different cores. Next slide, please. And then each one of those cores ended up with 6 actual unscrewing cores on them. So the project, although initially expected to be a 64 cavity through the design of the servo system, was actually reduced to a 48 cavity. This, of course, in very close conjunction with the mold maker and the mold owner. And this is driven off of one motor here, this particular application. And that's what was designed for this. Servo mold also, we do try to bundle the actual controllers with the drive mechanisms. That doesn't necessarily have to happen, although bundling with the servo controller is very convenient, because servo actually will write the initial control algorithms right at the mechanical design of the system, where we do, but if we do introduce a third-party controller, then that just creates a little bit more work for the mold designer to do with that controller supplier. Next slide, please. Again, very high level on that. I do apologize, we're so short on time. But again, servo has a lot of different applications, and we certainly would like to discuss your next plate movement or unscrewing opportunity with you. Moving into a standard mold component here, not necessarily customer application driven, but application driven with regard to the different products offered in our Easy Latch latch lock family of components. On the left there, you can see our original and standard Easy Latch lock for 3-plate control. And on the right, we have our R or reverse Easy Latch product, which is used for even more complex multiple plate control. Next slide, please. The standard Easy Latch for 3-plate control. For the configuration of this here, the latch lock body goes on the top clamp plate, the latch bar goes on the B plate, and the retainer goes on the A plate. And this little step diagram here shows the motion of the plates as the mold opens. Basically, the EasyL allows for precise 3-plate control during the parting line opening. The B plate and A plate move together for the designated stroke to strip the runner, and then the B plate disengages from the A plate, allowing the parting line to open. If we go to the next slide, please, here you will see where the different components of the Easy Latch mechanism are mounted, which plates they're mounted on. You see a kind of a cutaway view of how the internal latch mechanism works, how it's configured, and what it would take for the mold designer to configure the specific Easy Latch product for the mold that they're working on. And next slide, please. And we did introduce here about 2 months ago in the DME Part Solution or Cadenas platform, all of our Easy Latch products now have complete product configurators where the mold designer can go in, choose his application, whether it be for the EasyL, the REasyL products, and set strokes and so forth. And the part number will be configured automatically for them. So it will be easy then to contact DME customer service or go to eStore. And as importantly, or perhaps more importantly, the CAD is generated via the platform, so the mold designer can drop it right in into their design. Next slide, please. Application 2, 3, and 4 are all based on our reverse or REasyL latch locks. And again, these are for a little bit more sophisticated plate control, same principle as the EasyL product. I skipped over that the EZL latch lock uses an internal cam mechanism that's used to, to lock and release with the movement of the plates. The REZL products do not use that cam. All of the release and capturing of the plates is controlled via the latch bar and internal components in the latch body. The first application we have here for the REZL product is two-stage ejection bottom last plate control. Let's go ahead and move one more slide ahead, please, Mark. Here you can see, again, the mounting of the different components, where in this configuration, the body of the latch lock is mounted to the bottom ejector plate. The latch bar is mounted to the support plate, which is a fixed plate, and the retainer is on the top ejector plate. This configuration allows for precise control over the bottom last two-stage ejection process. Both ejector plates spaced apart move together for the designated stroke S1, so that would be the first movement. Then the bottom ejector plate is released and continues to move independently for the final stroke of the application, so the part can be ejected, or to eject the part. Next slide, please. Mark, did you advance the slides? I had a glitch there in my display. One more, please. Application 3, as noted there, is again an REZL product, and in this case, it's configured for two-stage ejection top plate last control. Next slide. Here again, you can see where the components are mounted. Again, we're using the same product. We're just configuring it slightly different and rotating in how it's mounted to the actual mold base. In this configuration, the body is on the fixed bottom clamp plate. The latch bar is on the top ejector plate, and the retainer is on the bottom ejector plate. So this configuration, as noted there, allows precise plate control over the top last two-stage ejection process. Both ejector plates move together for the first stroke S1, and the top ejector plate continues to move independent for the final stroke required to eject the part. So again, just opposite operation as the previous example. Next slide, please, Mark. And here again, I think I skipped over this previously, but again, this configuration is also fully configurable within Cadenas to help establish part numbers based on stroke and provide the CAD for the mold designer. And next slide, please. And the last application that we want to review this morning, as noted, another REZL application for bottom last stripper plate and ejector pin ejection. Next slide, please. Here again, looking at the mounting, in this case, the latch body itself goes on the ejector plate, the latch bar on the support plate, and the retainer is on the stripper plate, the B plate in this application. So this configuration allows for precise control of both the B stripper plate and the ejector plate. The stripper plate and the ejector plate move together for the first stroke S1. After that, this synchronized motion is critical for collapsible core applications. And then after that first stroke, the ejector plate continues to move independently for the final stroke needed to eject the part with ejector pins. So really crammed a lot in there in just a short period of time because we are so limited. Basically the intent of this quick presentation is just to demonstrate the versatility of the Easy Latch product line. These are all stock products for DME. If we go one more slide, please, Mark. Again, and I just wanted to make sure that the audience is aware that the Cadenas configurator is now fully up and running and available. Again, for part number creation and assistance. Sometimes it can be a little bit confusing for the mold designer to establish stroke and determine what he really needs in the way of a particular assembly. And the configurator as noted, will auto-generate part numbers and really facilitate that mold design, making it quicker and easier. Any questions at all with regard to the Easy Latch products? Our engineering team is readily available. It can actually help you if the Cadenas platform isn't sufficient for the work that you're doing. So thank you for your time. And again, any questions, please drop them in the chat and we'll address them at the end of the presentation. Thank you.
Okay, Neil, you're up. Check your mic.
Can you hear me?
We can hear you.
Good. Let's proceed. Okay. We're talking about the Crytex TM7 grease. We have a case study where a customer was experiencing pin breakage on some 12 millimeter pins in a high heat application. What we specified was the Crytex TM7, and he had applied the grease and actually went from 50 to 150 shots where he was receiving failures to over 10,000 shots without any breakage. Next slide. Also extended the runtime up to 13,000 shots without any failures. The high temp grease actually embeds into the surface of the metal on the pins and it won't migrate into the cavities. DME also recommends and actually provides collapsible cores with the Crytex grease on the mechanisms. Next slide. The Crytex is superior to a hydrocarbon grease, and we've done some testing in an oven where at 232C for over 40 hours, it shows that the Crytex had a 0 weight loss versus a hydrocarbon grease, which experienced 40% loss. So the Crytex is non-flammable. It doesn't have a flash point. It doesn't oxidize, so it does have a indefinite shelf life. There's longer maintenance cycles, exceptional lubricity, and it doesn't migrate from the point of application. Next slide. This shows just contamination of grease as determined by color. When using the Crytex, it's recommended that you wipe off your pins with mineral spirits or mold cleaner and a rag. And also you can start with new pins as well, which is recommended. We do supply the Crytex in grease gun. We do have small tubes of 2 ounces or 8 ounces if you'd like to try it. You could buy those. And we have small jars and pails available. Next slide, please. Here is the spec sheet on the Crytex TM7. Of course, everything will be available with the recording of this particular presentation. TM7 stands for tire mold grease, 7th formulation. And it's impervious to boiling water and steam. So it's a really good product. There's also a higher heat Crytex available, which is their valve grease. So if you need something over 555 degrees F, give us a call and we can talk about the higher heat grease. Next, we're going to talk about the Merkel AHP block cylinders, and we're comparing the block cylinder to a typical tie rod cylinder. As you can see, the block cylinder is one piece. It also is very robust. And next, the tie rod is roughly 7 pieces in the body. The block cylinder is a single construction, little more streamlined, less opportunities for leaks. Your line pressure on a tie rod cylinder's 250 bar, while a block cylinder is typically 500 bar, and a bar is 14.5 psi, so keep that in mind. The smaller cylinder can also be used in different configurations throughout the tool. A tie rod cylinder typically is mounted on the outside of the tool or on an extension plate, and the block cylinders actually can be buried into the tool design. Very, very streamlined. Also, one of the features of the block cylinder is you can get them with a cooling jacket. So if you're running high heat applications, either in die casting or some of the higher heat resins, you can protect the seals and the hydraulic fluid by adding that cooling feature. That is an option. Also, through the actual rod mount of the tooling components that actually meet the plastic, there are possibilities for actually adding a cooling channel, a bubbler right through the cylinder. Next, as you see, the tie rod mounted outside, you have hoses, and it's looks like it's not as neat as the solid cylinder on the outside on the right. Next. There's also many enhancements available. We have core pull slide carriers that you can just add to your tool to lessen some of the machining that you have to do to put a core pull on the side of a cavity, and that is all offered by Merkle. We also have flow dividers that help distribute to make a synchronous hydraulic cylinder circuit. And there's all sorts of switches that we can add on as well, and also mountings. Next. And if you have any questions, I can answer the question as well.
Perfect. Thank you guys for going over all of the products and case studies that we had right now. This pretty much, concludes our portion of the webinar, and we'll be opening this up for questions and answers. So if you do have questions, please put them in the chat, and Mike, Neil, and Jeremy will be able to get with you. While we're waiting for some questions too, I just wanted to highlight we are having our end of the year mold date insert program, so where you can save 10% off. So if you want to get ready for your 2026 mold date inserts, let us know, and we could help you save a little bit of money on there. Also, if you enjoyed this webinar and if you wanted other webinars, if you go to dme.net/webinar, you'll find all videos that we've had from previous webinars we have, and we also have a few more webinars for the rest of the year. that you can register for on there. So feel free to jump over there, and yeah, we'll be happy to help you out there. So,
all right, gentlemen. Yeah, gentlemen, thank you. A lot of information. You did it in less than 45 minutes. I'm impressed. All right. So why don't we let's get into some questions. And again, I do want to remind everybody, just use that question, the Q&A tab to answer questions. We do have some time. Remember to look at that handouts tab. There's plenty of information about the products that the three gentlemen spoke about today. All right. So can flow sense be added directly to the mold instead of the press?
Yes. Yeah, typically we just mount it on the side of the press, but yeah, you can mount it to the mold itself. Yep, no problem.
All right. All right, now we're going to go to the cooling care unit. So are there specific cleaning agents that need to be used with that machine? And then can you get into, if there are, I'm assuming there are, what are the key differences in their cleaning effectiveness, and how should somebody go about determining which one is best for their specific mold contamination issues?
Great question. Yes, there are two that we specify as approved cleaning agents. Those are purchased through DME as well, DS1 and DS2. The two products are mainly formulated for either rust, high rust iron content, and the other one's more for scale. It's slipping my mind at the moment which one's which, but yeah, those are the two approved. What we could do is take a look at what type of buildup you have in the system, and then suggest which type would be the best for your application. And it depends really on the water quality. Is it high iron content, or is it high scale? Hard water would be the key to that, to choosing one of the two.
All right. I believe you spoke about, for cooling care, there's a self-optimization feature. Is that correct?
Yes.
So well, the question is more around the lines of how does AI or any type of like intelligent algorithms help to automatically adjust cleaning parameters? Like, how does that play into this unit?
No AI currently. So typically what we do is, like I said, we do a baseline of when the tool is new, and then to get your flow rates going through there. And then we can set up program that by channel, by tool into the PLC. And then when you go to hook it up after it's been running, it can match those same parameters that you set prior. Right. So then the machine will say, okay, I should reach 2 liters a moment for flow rate, and I'll clean until I get to that 2 liters a minute. And then once that's achieved, it will stop the cleaning and then notify you that that channel is clean.
Got it. Do you offer any demos with cooling care to test how well it can clean channels?
Yes, we have a fleet of demo units. We can get in touch with the sales rep in your area, and they can discuss with you what unit might be best for your operation, and try to bring that unit in for a trial, and see how it works out for you. And you can see firsthand how to operate it, how quickly it works, and what type of results you'll get. So yeah, not a problem. We can do that.
Another one for Cool Care. It's about, okay, let me see if I'm getting this right. How does the Cool Care rust removal system, how much more effective is it over traditional rust removal systems in the case of efficiency, speed, and cleaning agents?
Well, personally, I think it's probably one of the quickest units. And for one, I don't see too many other units on the market that really tells you when you have achieved your goal. You set a goal of, the flow rate that you want to achieve, and the machine's monitoring it. And so typically everything else on the market is you just run it, and then you'll have to test it at some point, like every hour, every 2 hours, whatever you want to do. And the machine is able to do that for you without any intervention. So in my opinion, this is probably one of the fastest ones. It also implements those key characteristics I said earlier. It's about the heat, the pulsation, and the pumping of the liquid through there is really the key, in the scrubbing action that you get out of it. That's really the combining all those together is really what makes this machine the fastest one out there, in my opinion. And also, I didn't state this during the presentation, but you could actually run cooling care on a tool that's in the press. We've done that. We've had a customer call us and say, hey, we're running a 2-shot tool and I cannot go down. I've been down to one side, one cavity for too many weeks. I'm flying parts out. Do you have something that can help me out? We've been trying to run acid through it and nothing's working. So we got the machine out there and hooked it up while it was still producing, and was able to clean that channel up and get the other side running within I think 6 to 8 hours. So,
oh wow, that's a great point.
Mm-hmm.
All right, over to you, Jeremy. I think we're going to move over to some servo mold questions. Does servo mold handle collapsible core or just unscrewing cores?
Well, I suppose, collapsible core for the most part would be controlled just through plate movement. But if you wanted to use servo for plate movement, absolutely, that's one of the applications. And I just briefly touched on. The case study is really about unscrewing, but plate rotation, plate movement is definitely something that the servo product line will accommodate.
Where can I get your servo mold project outline or your quote request form?
That would be downloadable from dme.net, or you should be able to get it from your regional sales manager.
Okay. All right. So how about, you probably went over this a bit, but what considerations should they take into account, what a mold builder should take into account when integrating servo mold system into a multi-cavity injection mold to optimize synchronization, cycle times, and thread quality?
Well, so very first, when a mold designer sets out to design a mold and he's thinking about incorporating, an unscrewing device or any type of complicated system like that, bring DME in as early as possible into that design discussion. And so again, back to just the very, very high level general parameters that I put out in the presentation. We'll look at the part, the number of cavities. As a matter of fact, in that particular case study, I believe the goal was 64 cavity, but it ended up being a 48 cavity due to size and so on and so forth. So I'd say get us involved very early between the DME application engineers, the servo mold engineers. All of those things that were just mentioned in that question will be addressed through, the customer meetings that we would have when we approach a project, and make sure that the outcome, of the entire system is agreeable, both with, the mold designer, the mold owner, and of course, DME and servo, who's going to be providing the system. So it's kind of a complicated question to answer very directly.
Got it. Block cylinders, I believe that was Neil. If none of the block cylinders in your brochure will work for me, are there other options?
Absolutely. Custom cylinders are available through Merkle, and we can help you with that through our mechanical engineering department.
Easy enough. And we still have a few minutes left for more questions if people want to use that Q&A tab. The Easy Latch series, do you have any advice on how somebody should evaluate how to select the appropriate Easy Latch in the series?
So again, I really wanted to highlight our Part Solution Cadenas platform that now has a full-fledged configurator for both the EZL product and, more importantly, the REZL product. So our engineering team, commonly spends a lot of time with customers on specifying, which product would be right for their application, describing the orientation, supplying a model, and so forth. We're happy to do that, but the Cadenas configurator is really a tremendous design asset, right? I mean, the mold designer can actually choose the application, as we discussed, top top last, bottom last, etc. Choose that application from the configurator, and then just input what the strokes need to be for as far as plate movement. And again, it'll generate a part number for you, and it will provide the CAD in either a mold open or mold closed configuration.
All right. Back to the servo. Can servo core pulls be timed for partial and sequential core pulls?
So again, generally, I'm going to answer that question yes, because again, the servo-driven drive with the encoder feedback tied in with the controller, yes, is going to allow very precise control of that movement timing. So most definitely.
Okay. The Crytox TM7. Did you, or maybe you already reviewed this, or maybe you can review it again. What are any practical limitations or specific application considerations someone would make, especially when it comes to compatibility with certain mold materials or potential for over application or cost effectiveness for low volume production?
Well, you're going to pick it because of the lubricity requirements that you have. And it's typically a higher heat application. Of course, you want to clean it prior to application. Some people choose to use a very small parts brush just to put a very, very little on there. You don't want to overdo it. It is very expensive. And you want to probably keep it as clean as possible too, as in any moving application. But as far as limitations, it's always the heat. This particular grade's good to 550. Then we get into their next grade, which is the valve grade, which I'm not entirely familiar with, but I can find out information on that if there's a higher heat requirement.
Excellent. All right, good. Gentlemen, any final takeaways you want to leave the audience with? And I want listeners to remember that this was recorded, so you will be able to listen to it later online and share it. Final takeaways.
Yeah, just the last thing. I'm going to be putting a few links over in the chat for everyone. I think we're having a little bit of a problem with our handouts, and we will be sending out the handouts to everybody who registered as well, just so you do have them. So other than that, unless Mike, Jeremy, and Neil have anything, I just want to thank everyone for coming and attending, and we look forward to helping you out in your next project.
Anyone else?
I was going to agree. If you guys, you have an application.
All right, excellent. Well, for all those listening, if you want more information, again, check out the handouts, check out the contact information. And I want to thank the organizers for helping this webinar run smoothly. And most importantly, I want to thank everybody for joining us and listening in. And lastly, you can visit moldmakingtechnology.com for this webinar and all archived webinars. It concludes today's webinar. And again, I'm Christina Fugis with Mold Making Technology. Have a great rest of the day.